All right, guys. Um, Today we're going to try something a little different. We're going to take a look at our next set of notes, but I'm going to basically be walking you through with this video, and I'll be letting some questions go that you can work on individually or with partners, but this will get you started with the main points I'd like you to get for today. So, we're going to take a look at systems of equations. Now, as far as the keystone goes, this is by far one of the most important things you're going to run into. It's a heavy load in terms of what you're going to see on the keystone, and if you feel comfortable doing this, you're really going to feel better off in the long run when you're taking this test. So here we go. We're going to jump in here. Here's standards are up top, but two or more linear equations in the same variable form a system of linear equations. Okay, so here's an example. Equation 1, x plus 2y equals 5. Equation 2, 2x minus 3y equals 3. A solution of a linear system in two variables is a pair of numbers a and b for which x equals a and y equals b. Make each equation a true statement. The point a comma b that lies in the graph of each equation is called the point of intersection of the graphs. Okay, so basically when we're doing graphing, the solution is going to be where the lines cross. Okay, because secretly deep down every mathematician's a pirate, so x marks the spot, as I like to say it. It's a really bad joke, so you can laugh at that if you'd like. So we're going to take a look at an example down here. Okay, practice using the graphing method to solve the linear equation. Write the solution as an ordered pair. So x plus y equals 4, 2x plus y equals 5. Our goal first is I want to use this. Okay, you'll notice we have a y equals button. In order to use this, I got to get y equals on this one by itself. So for the first one, subtract x over. I get y equals negative x plus 4. So there's my equation number 1. All right, circle that for you. My second equation, I'm going to subtract 2x over. Y equals negative 2x plus 5. Here's number 2. All right, good. Now, there's negative 2x, by the way. So now that I have two equations, I'm going to go to my calculator. I am typing this in exactly as I see it. Negative x plus 4. There's my equation 1. Down to y2. Negative 2x plus 5. Okay, so I'm going to double check myself. Does this match up? Yep, we're good. So everything's good. Graph it. There's my first line coming down. There's my other line. All right, now, here's the thing. I want to know where they crisscross. Okay, like where is this point? Now, there are some arrows on your calculator, and you can kind of maneuver them around a bit. It's a little frustrating because you don't know for sure. Roughly, it looks like 1 around there, but I want to know for sure. So there is a way to do this, okay? We're going to hit, follow me on this one, okay, second, and the trace button. Now, we want to know where these two lines intersect. Okay, out of the possibilities here, I'm coming down to number 5, intersect. So we're going to hit the enter button then. Enter. All right. Here's a nice part. It says first curve. I don't have to do anything. The calculator does it for you. I'm going to hit enter again. Then it says second curve. Let's hit enter one more time. Then it says guess. Would you like me to guess? I always have a conversation with my calculators. Why, sure. I'd love for you to guess this problem for me. So I hit enter one more time. And once you know it, it gives you the exact answer right here. My x is 1, my y is 3. Okay? So I know at 1, 3, this is where my two graphs intersect. So down here I can say answer 1, 3. Okay, if we were asking for a quick sketch, you could do something like this. Down to the right. This one's coming down like this. There we go. Okay. But that's how easy these become if you can use this calculator. All right, just one more time to show you guys, okay? So I'm going to go to y equals, you type everything in, hit graph, all right? Then once they're graphed, second, trace, intersect, number 5, enter, 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 okay? So I'm going to get you guys started number 2, and I'm going to let you finish it on your own. We want to get y by itself. So for equation 1, subtract 3x over. I get negative 2y equals negative 3x plus 2. Divide both sides by negative 2. I get y equals, okay, we get negative 3 divided by negative 2 is 3 halves x minus 1. 2 divided by negative 2 is negative 1. So there's my number 1 equation. This is what you're going to type into y1. y2, okay, I want to get this by itself. Let's see, add 2y over, 2y plus x equals 6. Subtract the x over, divide both sides by 2. So y equals negative 1/2 x plus 3. There's my number 2. Okay? Type this one in, type that one in, and let's see what you guys can come up with. Okay? Now, you may pause the video right here if you'd like, just to try that out real quick, and I'll be walking around the room to help you guys out. Okay? I'm going to go ahead, once you're done, okay, going to come down here to number 3. So, number 3, write a system of two linear equations that has a given number of solutions. Write each equation in slope-intercept form. How are the slopes related? Sketch what their graphs would look like. Okay. One solution. If I wanted to have one solution, you could even do something like right up here. Okay, like I know I'm not like coming up with anything brand new, but I could say something like x plus y equals 4, 2x plus y equals 5. All right. So same idea here. If I would have gotten y by itself, I get the negative x plus 4. How am I doing this? Just see above. And y equals negative 2x plus 5. All right. So this was one solution. We saw that the x marked on our graph and it all went well. For example of no solution, okay, let's try something like 2x plus 1, y equals 2x minus 3. Okay. Now, why in the world would I do that? Hopefully, if you recall from before, y equals mx plus b. What do you notice about these two slopes? Well, they're identical. They're both 2. If I were to graph this, okay, so 2x plus 1 and 2x minus 3. We have a line coming up, and we have another line coming up. Well, these are special kinds of lines. Okay, anybody from my geometry class knows these are parallel lines. Parallel lines never intersect. If your lines do not intersect, you have no solution. There's no way, there's no X marks the spot. You're done. Okay? Now, lastly, infinite many solutions. Y equals, let's say, like 2/3 x plus 1. Y equals 2/3 x plus 1. Okay? So something like this. Now notice we still have the same exact slopes, but look at your y-intercepts. What's unique about these compared to that? Here, they're different. On the right, they're exactly the same. So if I graph these, I just want to show you this real quick. It's kind of neat. And yes, some things in math can be neat. We've got parentheses 2 divided by 3 plus 1, parentheses 2 divided by 3, x plus 1. All right. If I graph this, well, hopefully this is going to kind of make sense. There's my two graphs. It's the same graph. Okay, like it's exactly the same. That's where I get my infinite many solutions from, because they're just overlapping. Okay? Awesome. Now, let me get you guys started here in the back with number 1. We should be in good shape. Absolutely, buddy. All right, guys. So that was Mr. Keeley stopping by, who just happens to be the coolest teacher in the world. So, sorry for the pause, but we're getting back to it. So, I'm going to show you guys one more. Okay, I'm going to let you guys try this one out. But another method to solve a system of linear equations is by the substitution method. If you would like, if you go to my webpage, there is a video on how to do this as well. So, I mean, you got my video, you have extra videos. There's tons of resources here for you. So, use the substitution method to solve the linear system. You're trying to get something by itself. Okay? So, in this case, if I look at the first one, 2x equals 8, I can get x by itself. How do I do that? Well, I'm going to divide both sides by 2. I get x equals 4. All right, looking sweet. But now I want to find y. I can take this and plug it back in. Okay? So if I put a 4 in for x, 4 plus y equals 2. I can subtract 4 from both sides. Y equals -2. Now, do yourself a favor. Don't leave your answer like this. Okay, every answer in this section is going to be an ordered pair. So 4, comma, -2. Boom, got it. All right, now I'll show you one that's a little bit more involved. I'm going to get you started on this one. Let's see, I can get either x or y by itself. I'm going to go with y because it's already positive, and I'm an optimistic kind of guy. So I'm going to go ahead and add x over. Y equals x plus 1. Now, notice that I have y equaling this value. I'm going to look at my second equation now. Everywhere I see a y, I'm going to replace it with whatever y equals for the first equation. So I'm going to go ahead and put in an x plus 1 here. So this is the tricky part. In the first equation, we got y equals x plus 1. My second equation, I substituted in x plus 1 for y. Okay? So take a moment now. I'd like you guys to try and solve this on your own. Combine like terms. I'll even drop the parentheses so it's less confusing for you. Once you get x, okay, you may plug it back in, solve for y, okay, and you have your first order pair, or your order pair for that solution. All right, give this one a try then too, your application, and we'll kind of sum everything up together at the end of the period. Again, good work today. Hopefully this helped a little bit. Keep up the good work. Just so you know, we're all counting on you.